I'm Michele Trott, Scientific Content Manager at Izon Science. Today, we'll be looking at the importance of quantifying the size of lipid nanoparticles, or LNPs. I'll also discuss the general approaches used when comparing and reporting particle size. LNPs containing mRNA played a critical role in making COVID-19 vaccines a reality. Fueled by this success, there is now a particular focus on LNPs, as particles that can be engineered to carry mRNA and other molecules for cancer therapy, vaccines, and more. Given the intricate production process of LNPs, precision in particle analysis is absolutely vital to optimizing formulations and ensuring high-quality production. While nanomedicine regulations are a work in progress, fundamental attributes come up frequently in draft and proposed guidelines. Of note, the FDA has listed physicochemical properties that should be reported as part of the pre-market application. Among this list is particle size, and this is one which is unlikely to disappear from the list of data points that regulatory bodies want to see. Therefore, monitoring LNP size is vital for product development and quality control. Any detection of larger than expected particles could be indicative of particle aggregation, which is crucial to identify, as this can hint at particle instability. Identifying aggregates could suggest a need to refine processes in manufacturing, storage, or transportation. And it goes without saying that sample instability and aggregation can compromise product efficacy and safety. In nanomedicine, particle size is expressed in three main ways. The first is to give the mean or mode particle size with an appropriate measure of error. The choice of mean or mode depends on whether your particles are normally distributed. If they are, this indicates that the mean should be used. And if the distribution is skewed, the mode is more appropriate. So far, so easy. The second method is to look at the distribution of the particles within your sample as it relates to size. This is the aptly named particle size distribution, and it visually shows what the size distribution looks like and how it compares to other samples. Finally, the polydispersity index gives an idea of how polydispersed your sample is by looking at the relationship between the standard deviation and the mean size of particles in your sample. This is a numerical value which can be used to compare LNP quality, with lower polydispersity indexes preferably lower than 0.3 being more favourable, as they suggest a more monodisperse and stable lipid nanoparticle population. So how are these properties measured exactly? For many years, the default method has been one that, despite its simplicity of use, has significant limitations. Now, spoiler alert, that method is dynamic light scattering, or DLS. To understand more about the constraints of DLS and how you can enhance your particle analysis using tunable resistive pulse sensing, stay tuned for our next video on LNP analysis. And don't forget to explore the resources linked below to read how TRPS and DLS compare. Thanks for watching.